Hello everyone, welcome to my channel. In this video, I am going to discuss two very important concepts in machine learning. They are underfitting and overfitting. These two concepts play a major role in understanding how well a machine learning model learns from data. A model should not learn too little and it should not memorize everything from the training data. Finding the right balance is very important for building accurate and reliable machine learning systems. In this video, we will discuss what is underfitting? Reasons for underfitting. Effects of underfitting. Solutions for underfitting. What is overfitting? Reasons for overfitting. Effects of overfitting. Solutions for overfitting. Let's begin by understanding underfitting. Underfitting is a situation in machine learning where a model is too simple to learn the important patterns present in the training data. Instead of understanding the relationship between the input and output, the model learns only a small amount of information. Because of this, it fails to make accurate predictions. An underfitted model performs poorly not only on the training dataset but also on new or unseen data. This means the model has not learned enough from the available data to solve the problem effectively. Think of it like a student who studies only one chapter for an exam while the exam covers 10 chapters. Even though the student attended the classes, they did not learn enough information to answer most of the questions correctly. Similarly, an underfitted machine learning model does not have enough knowledge to make reliable predictions. For example, imagine we want to predict house prices. House prices depend on many factors such as location, area, number of bedrooms, age of the house, nearby schools, transportation facilities, and market demand. If our model considers only the number of bedrooms and ignores all the other important factors, it will produce inaccurate predictions. This is a classic example of underfitting. From the graphs, we can see the model in case of underfitting fails to detect the patterns present in the data, whereas the model which does not underfit captures the true patterns present in the data. In simple words, underfitting means the model has learned too little from the data or the model failed to detect or learn patterns from the data. Now let's discuss the reasons for underfitting. There are several reasons why underfitting occurs. The first reason is choosing a model that is too simple. Some problems are naturally complex and require advanced algorithms. If we use a very basic model for such problems, it cannot capture the hidden relationships present in the data. Another reason is insufficient training. Machine learning models need enough time to learn patterns from the data. If training is stopped too early, the model may not fully understand the information. Using too few input features can also lead to underfitting. When important information is missing, the model cannot make accurate predictions because it does not have enough knowledge about the problem. Excessive regularization is another common cause. Regularization is used to prevent overfitting, but if it is applied too strongly, it restricts the model from learning important patterns. Poor feature engineering is also responsible for underfitting. If the input data is not properly prepared, cleaned, or transformed, the model may struggle to identify meaningful relationships. Let's talk about the solutions for underfitting. Fortunately, underfitting can be corrected using several techniques. One solution is to use a more powerful or complex machine learning model. Advanced algorithms can capture more complex relationships within the data. Another solution is to train the model for a longer period. Increasing the number of training iterations or epochs allows the model to learn more effectively. Adding more relevant input features also improves learning. Including useful information gives the model a better understanding of the problem. Improving feature engineering is another effective solution. Properly cleaning, transforming, and selecting features can significantly improve model performance. Reducing excessive regularization also helps. If the regularization strength is too high, decreasing it allows the model to learn more from the data. Finally, collecting more high-quality training data can improve the learning process and reduce underfitting. The main goal is to provide the model with enough information and flexibility so that it can learn the true patterns present in the data. Now let's go and understand what overfitting is. Overfitting occurs when a machine learning model learns not only the useful patterns in the training data, but also the random noise and unnecessary details. Instead of learning general rules, the model memorizes the training data. As a result, the model performs extremely well on the training dataset, but fails when it encounters new, unseen data. Imagine a student who memorizes every question and answer from previous exams without understanding the concepts. During practice tests, the student scores very high because the questions are familiar. However, when the final exam contains new questions, the student struggles to answer them. An overfitted model behaves in exactly the same way. It memorizes the training data instead of learning the actual concepts. For example, consider an email spam detection system. If the model memorizes the exact words used in training emails instead of learning the general characteristics of spam messages, it may fail to recognize new spam emails written differently. From the graphs, we can see the model in case of overfitting tries to match almost all the data points, including the noise and the outliers, whereas the model which does not overfit captures the true patterns present in the data. In simple terms, overfitting occurs when a model memorizes the training data instead of learning the underlying patterns. As a result, it achieves very high accuracy on the training data, but fails to generalize and performs poorly on unseen data. Let's talk about the reasons for overfitting. There are several reasons why overfitting happens. One major reason is using a model that is too complex. Models with many parameters can easily memorize the training data instead of learning meaningful patterns. Another reason is having a very small training data set. When only a few examples are available, the model tends to memorize them instead of discovering general trends. Training the model for too many epochs can also cause overfitting. After learning the useful patterns, the model starts learning random noise from the data. Noisy data is another important reason. Errors, incorrect values, and outliers can confuse the model and reduce its ability to generalize. Using too many unnecessary features also increases the chances of overfitting because the model focuses on irrelevant details. Finally, not using regularization techniques such as L1 regularization, L2 regularization, dropout, or early stopping allows the model to become unnecessarily complex. Now let us discuss the solutions for overfitting. There are several proven techniques to reduce overfitting. One of the most effective methods is collecting more training data. A larger and more diverse dataset helps the model learn general patterns instead of memorizing specific examples. Another solution is to simplify the model. Reducing the number of parameters or choosing a less complex algorithm lowers the risk of memorization. Regularization techniques such as L1 regularization and L2 regularization help prevent the model from becoming overly complex by adding penalties to large model weights. Cross-validation is another important technique. It evaluates the model on different subsets of the data and helps identify overfitting before deployment. Early stopping is widely used in deep learning. Training is stopped when the model's performance on validation data begins to decrease, preventing it from learning unnecessary noise. Dropout is another deep learning technique that randomly disables some neurons during training. This forces the network to learn stronger and more general features. Removing irrelevant or unnecessary features through feature selection also reduces overfitting. Finally, ensemble learning methods such as random forest and gradient boosting often produce models that generalize better than a single complex model. The ultimate goal is to create a balanced model that learns meaningful patterns while ignoring unnecessary noise. Such a model performs well on both training data and completely new, unseen data, making it reliable for real-world machine learning applications. That's it for this video. Thank you for watching. If you found this explanation helpful, don't forget to like the video, share it with your friends, and subscribe to the channel for more machine learning and artificial intelligence tutorials.